my name is Elisha binti Patrick from DPE 3 Section 1. In this video, I'm going to discuss about Experiment 3, the comparison of pressure measurement by manometers and Bourdon gauge. Measuring pressure is important in the engineering industry, for example in plant turbo machine and aircraft construction, and in process engineering. Other fundamental factors such as flow rate or flow velocity can also be determined based on a pressure measurement. The D1201 experimental unit enables the user to measure the pressure with two different measuring methods, directly by measuring the length of a liquid column, U-tube manometer, inclined tube manometer, and indirectly by measuring the change of a shape of a Bourdon tube pressure gauge. In a U-tube manometer, the pressure causes the liquid column to move. The pressure difference is read directly from a scale and is the measure for the applied pressure. In inclined tube manometers, one leg points diagonally up. A small height difference therefore changes the length of the liquid column significantly. The principle of the Bourdon tube pressure gauge is based on the change in cross-section of the main Bourdon tube under pressure. This change in the cross-section leads to an expansion of the Bourdon tube diameter. A Bourdon tube pressure gauge is therefore an indirectly acting pressure gauge where the pressure differential is indicated via a transmission gearing and a pointer. In these experiments, pressure in the millibar range are generated with a plastic syringe and displayed on the manometers. The experimental unit is equipped with two Bourdon tube pressure gauges for measuring positive and negative pressure. The U-tube manometer, inclined tube manometer, and Bourdon tube pressure gauge at the experimental unit can be combined using tubes. First, the tubing from the U-tube manometer and Bourdon pressure gauge PG101 being connected to the T-piece. Next, another short tubing connected to the T-piece. Third, the syringe ensured to extended until 60 ml and connected to the short tubing. The plunger of syringe being pushed 2 ml inward. Waited for the manometer reading to stable and the syringe cannot be released. The reading of the manometer H1 and H2 and Bourdon pressure gauge being recorded in table 3.1a. Steps 6 and 7 of the experiment being repeated by push every 2 ml inward until the water level either side of manometer is below the indicated line. For the inclined manometer, the previous setup remained but the tubing from the U-tube manometer being disconnected and connected to the inclined manometer instead. The syringe be removed from the flexible tubing and ensured to extend it until 60 ml. The syringe also reconnected to the short tubing and the final setup as shown. The plunger of syringe being pushed 2 ml inward, waited for the manometer reading to stable and the syringe cannot be released. And the reading of the manometer H1 and H2 and Bourdon pressure gauge being recorded in table 3.1b. Steps 6 and 7 of the experiment being repeated by pushing every 2 ml inward until the water level in either side of manometer is below the indicated line. For the vacuum measurement of U-tube manometer, First, the tubing from the U2 manometer and Bourdon pressure gauge, PG102 being connected to the T-piece and another short tubing connected to the T-piece. Next, ensure the syringe at 0 ml and the syringe being connected to the short tubing. The plunger of syringe be pulled outwards in 2 ml. Waited for the manometer reading to stable and the syringe cannot be released. The reading of manometer H1 and H2 and Bourdon pressure gauge be recorded in the table 3.1c. Steps 6 and 7 of the experiment being repeated by pushing every 2 ml inward until the water level in either side of manometer is below the indicated line. From the graph, we can see that the pressure in bar is increased linearly with the increases in the volume of air injected and the volume of vacuum for graph 3. The values of the uncertainties have been shown in the graph as well. The value of the pressure obtained in PG101 for graph 1 and 2 are higher than the pressure obtained on U2 manometer. It is H in bar. Eventually, for the reading of the pressure on PG101 on the graph 3 is lower than the reading from U2 manometer. We also can see from the table 3.1a, B and C that the values that we obtain through calculations and those written on their labels are almost the same as the values that we have obtained through the PG101. Besides, for the percentage error on the table 3.2a, B and C, most of it has some error. By using the correct formula to get the percentage error, we got a valid error. Furthermore, we got a big errors between the H reading and the PG101 reading. It is maybe caused by the calibration of the Bourdon gauge is not yet perfectly calibrated, so it caused a little bit errors obtained. In conclusion, pressure measurement using manometers is a very widely used technique and gives us accurate results. We have seen from our readings that the expected values and the obtained values were almost similar. One thing that we had to keep in mind using the Bourdon gauge manometer that the scale reading has an initial calibration error, which could be result of air bubble present in the linings of the piston. Furthermore, it was a short experiment and did not require many efforts. More than 3 manometer readings were taken so as to take mean of a larger number of values to make the results as reliable as possible. That's all from me. Thank you.